There's this equation which you probably want to know for the test. You won't see it in the PMBOK guide, but you'll see it in most of the leading study guides. It says that our standard deviation sigma is approximately equal to this quantity p minus O divided by 6, where p is our pessimistic estimate and O is our optimistic estimate. And in addition to this, there's a few other related things we're going to want to memorize for the test. These values here of plus or minus 1 sigma equals 68.26%, plus or minus 2 sigma, 95.46%, plus or minus 3 sigma, 99.73%, and plus or minus 6 sigma, 99.9997%. And then also we have the statistical variance, which is equal to sigma squared. So that quantity p minus O divided by 6, all squared. Okay, now if we go back to our original equation and multiply through by 6, we see that we have 6 sigma equals p minus O. And if we look at a normal bell-shaped curve and plot p and O here, and whether we're talking schedule or cost, a larger value is worse. So our pessimistic estimate is being shown on the right side, optimistic on the left side, and the distance between is 6 sigma. That's what this equation is telling us. And the normal bell-shaped curve is symmetric about the mean, so what we have here is plus or minus 3 sigma about the mean, which relates to that 99.73% confidence interval. So what this is saying is we've selected our pessimistic and optimistic estimates to encompass 99.73% of all possible outcomes, and the remainder is the other 0.27%, half of which is in each tail. If we wanted to look at plus or minus 2 sigma, we see this narrower range, which encompasses 95.46%. Coming back to the plus or minus 3 sigma, again, just to reiterate, this equation is implying that we dial in 99.73% confidence interval when we select our pessimistic and optimistic estimates. So again, this is only a very rough approximation. You're going to want to memorize it for the test. Probably should go on page 2 of your brain dump, but then after the test, I would suggest you disregard this equation. In the real world, you want to use real statistics.